In this video, we're going to start a new unit on integration. In a previous unit, we looked at integrating polynomials. Let's just remind ourselves of that. If we had the integral of x to the n dx, we could write this as x to the n plus 1 divided by n plus 1 plus c, where n could not be equal to negative 1. So all we did with this was raise by a power, divide by the new power, and add a constant of integration. So an example, if we had now the integral of 3x plus x squared dx, we could write this now as raised by a power, so it becomes 3x squared, divide by the new power, raised by a power, x cubed, divide by the new power, and add c. So all I've done is integrated this polynomial. This is what we call an indefinite integral. An indefinite integral doesn't have limits. When we don't have limits, we introduce this arbitrary constant c. What we're going to do in this video is look at definite integrals that have limits. In later videos, we will look at the area trapped under a curve, but for now, I just want to evaluate a few definite integrals. So let's look now at a definite integral. With a definite integral, on our integration sign just here, we will have limits a and b. What I'm going to write here now is a derivative, and I'm just going to write f dash of x. We don't have to, we can just have some function of x. But if I have a derivative that I want to integrate, or a function I want to integrate, and we can integrate this and evaluate it between a and b, we can say that this is going to give us now f of b minus f of a. If you wanted, you could write this now as the integral from a to b of f of x dx, and this would now give us, and we would have a function, and the function that would arise is simply now the integral of this. We would do f of b minus f of a. So either one of these is perfectly fine. The question is, do you need to know that? Well, the answer really is no. All you need to do is be able to integrate and evaluate. So let's look at a very straightforward example of a definite integral with limits. So what I'm going to do is integrate a function between x is equal to 1 and x is equal to 2. And that is simply going to be, now let's go for 2x plus 5. So we're going to integrate this. So all I'm going to do is integrate each of these. If I integrate 2x, I'm going to get x squared. If I integrate now 5, I'm going to get plus 5x. At this stage, we can now evaluate. And the way I do that is to put my limits of 2 and 1 like so. You're probably thinking, well, where is c? With a definite integral, we don't need to have c, as they will cancel out. You can include it, but as you'll see, it cancels out. So all I've done here is simply now found a new function, which, if you like, if this was the derivative, this here is the integral. Or if you like, if this was the function here, this is some new function. So what I'm going to have here is now evaluating. Remember, this right here is b, so we're going to have now 2 squared, which is going to be 4, plus 5 lots of 2, which is going to be plus 10. And then we subtract away 1 squared, and then we're going to have plus 5 lots of 1, which is 5. So all I've done is substituted in here, then I'm subtracting away, substituting in the 1. So I've done f of b, which is just here, minus f of a, or if you like, this new function, if you define it like so. I think it's quite nice to write it as this as the derivative, and you can bring back the function. I think it makes slightly more sense to do that. So all we need to do here is evaluate this. Well, that's going to give 14, and then that's going to give 6. 14 minus 6 is equal to 8. So we can say now that the integral from 1 to 2 of 2x plus 5 dx is equal to 8. So the way we do this is integrate and then simply evaluate. So if you'd written plus c, of course you're going to get plus c in here, plus c in here. C minus c is 0, so we don't need to have it. So let's look at the difference between an indefinite and a definite integral. The same process occurs. Raise by a power, divide by the new power for a polynomial. This time though, where we have limits, so the limits of integration right here, as long as we can integrate this function and it's continuous between a and b, we simply find the function, evaluate b, and then evaluate a and take away. So let's go ahead and do some of these. So evaluate the following integrals, giving your answer to 3 significant figures where appropriate. So on the first one, we've got now the integral from 1 to 4. So these are the x coordinates. And then what we're going to have is 2x plus 1 dx. So all I'm going to have here is the following. We've just seen now that 2x integrates to x squared. 1 is going to integrate to x. I'm interested in this now from 1 to 4. So substituting in 4, we're going to get now 16 plus 4. We substitute in 1 and subtract that away. That's going to be 1 plus 1. Well, that's going to be 20, that's going to be 2, and that is going to be 18. So that now gives us the value of the integral from 1 to 4 of 2x plus 1. In the next video, we're going to look at this in terms of the area under a curve. If we think what we've got here, and I'll just draw this up because I think it's important to show this. If I look at this particular function here, I could go ahead and if I wanted to draw the graph, we could factor this as x and then x plus 1. So that factors to x plus 1, which is going to look something like so. So that's negative 1, it will come back through the origin and so on and so forth. What we've just done here, this coordinate here of 1, and then we'll have some coordinate up here, and it's not massively accurate in terms of its scale. We can use integration and the definite integral, as we'll see in the next video, to find the area trapped between a curve and the x-axis. So if we wanted this area, we could say that the area was equal to the integral from 1 to 4 of 2x plus 1, and we are now integrating with respect to x. As stated, that is one of the uses of a definite integral, and we can see that in the next video. Okay, next one, we've got the integral now from negative 2 to 0 of x squared plus 3. So let's go ahead and integrate. We're going to have 1/3 x cubed, raised by a power, divide by the new power, plus 3x, and we're interested in this now from, and this is going to give us from now negative 2 to 0. So what we're going to have is 0 plus 0. Then we subtract away. Now if I substitute in negative 2, negative 2 cubed is negative 8. So that's going to give me now negative 8 over 3. And then we're going to have now from that, we're going to subtract 6. So subtract 6. So what's that going to be? Negative 26, negative. So let's put 0 minus, and then we're going to have now on here negative 26, 26 over 3. So that gives us a value of 26 over 3. So all I've done is integrated and evaluated. We can get a negative answer for an integral. That would be perfectly fine. And again, we will look at what that means in a later video. Okay, question C, we're looking at now at the integral from 2 to 4 of 3, and then I'm just going to write this now as we're subtracting away x to the negative 2, and that is dx. So what we're going to get then is 3x. We are going to raise by a power, so that will be x to the negative 1, divide by the new power of negative 1, and we're interested in this now from 2 to 4. Okay, let's just tidy this up. I can write this as 3x. The negatives, two negatives divided give a positive, and x to the negative 1, we can write this as 1 over x. So I've just tidied that up. You certainly don't have to, but it might help you out. So substituting in 3 times 4 is 12, plus now 1/4. Then we're going to subtract away from that now 6 plus 1/2. So what's that going to be? 49 over 4. So again, you can do this on a calculator, and that is going to be 13 over 2, which is going to be 26 over 4, which should now give 23 over 4 as a simplified fraction. Again, if you want to check that in a calculator, perfectly fine. So 12 plus 0.25, and then we're going to subtract away from that 6 plus the 0.5. Do a lot of simplifying, and 23 over 4 gives us that value. Okay, let's look at the next one. D, we've got the integral from 1 to 8 of 3x minus 1 over 2x squared minus root x. So let's do some tidying. We're going from 1 to 8, so the x coordinate 1 to the x coordinate 8. We can have 3x. I'm going to write this now as negative 1/2 x to the power of negative 2 minus x to the power of 1/2, and we have dx. So let's go ahead and look at that. That's going to give me now 3x squared over 2. I'm going to raise by a power and divide by the new power. That is going to give me, so raising by a power is going to be negative 1, divided by negative 1. So I'm going to write this now as 1 over 2x. Raise by a power, divide by the new power, 2 over 3, and then we're going to have x to the power of 3 over 2. And we're interested in this from 1 to 8. So I've done the simplifying here. If you want to take your time and do that, that is going to be perfectly fine. Okay, at this stage now, we would generally have to show our workings, and all I'm going to do is evaluate now the 8 and the 1. So what's that going to be? 64 times 3, so that's going to be 96 in the first one. If I substitute 8 in there, that's going to give me 96. So 96 plus 1 over 16 minus now 2/3, that's going to give me minus 8 over, what are we going to have? That's not going to look pretty at all. So let's just write that in. 8 to the 2/3. In fact, I'm just going to put that into a calculator. So what's that going to be? That's going to be 2/3, and then we're going to have 8 to the power of 3 over 2. 8 to the power of 3 over 2. And then we're going to substitute in 1, so that's going to be 3 over 2 plus 1 over 2 minus 2 over 3. Okay, so we're rounding to 3 significant figures where appropriate, so let's go ahead. 96 plus a 16th plus 1/16 plus now, so minus, and then we can have 2 lots of 8 to the power of 1.5. This really is going to be messy. 8 to the power of 1.5 over 3. And then we are going to subtract away from that. Well, that's going to give me 2. So 2 minus 2/3. I'll let you do the calculation. Hopefully you can see the processes at least, right? Right, there we go, 79.6. So 79.6, and that's now to 3 significant figures. So all I've done is substituted in and gone ahead and found that particular answer. Again, show your workings if you're asked to in an exam, and do be explicit in what you're doing. Okay, next one, what have we got? We've got now the integral from 2 to 4 and we've got now x to the negative 2 minus now 3x to the negative 4 and we're integrating with respect to x. So what are we going to get here? We're going to get now negative x to the negative 1, or negative 1 over x. Then this right here is going to give me now plus x to the minus x to the negative 3, or 1 over x cubed. Again, I'm hoping that your skills learnt in the previous unit will allow you to manipulate those indices. If I raise by a power, I'm going to get negative 3. So negative 3 divided by negative 3 is 1. So we end up with this right here. So let's go ahead and do that. So what we're going to get is negative 1 over 4 plus 1 over 64. I'm simply substituting in here. Then we're going to get now, so we're subtracting now negative a half plus 1 over 8. So let's go ahead and work out what that is. So we've got now negative 0.25 plus 1/64. So plus 1/64, and from that we're going to subtract now, what have we got? Negative 0.5, negative 0.5 plus 1 over 8. And that should give us now 1 over 8. Let's get in the denominator. 1 over 8. There we go. And that is going to give me now 9/64, or 0.141. So 0.141 to 3 significant figures. Let's just check that. That's fine. I'd like to leave it as an exact fraction, 9/64. So I think that looks a bit tidier. Okay, let's do the next one. So what have we got? The integral from 3 to 8 of x to the half, then minus 2x to the negative 3 over 2. So let's go ahead and do that one. The integral from 1 to 8, and then we've got now x to the 1/2, and then we're going to subtract from that 2 lots of x to the negative 3 over 2, and now we've got dx. So if I raise by a power, that's the 3 over 2 power, so we get 2/3 x to the 3 over 2. Remember, if I'm dividing by 3 over 2, I'm multiplying by 2/3. If we raise by a power, that's going to give me the power of now negative a half. So negative 2 divided by negative half is going to give me plus 4. So this is going to be 4x to the negative 1/2, and we're interested in this from what were we on there? 3 to 8, isn't it? Let's just change it over. Okay, so there we go. That's what we end up with, and we'll just simply substitute this in and find the value. I'm not going to show the workings. We'll just go ahead and do that. So what we've got then is 2. So let's put this in, 2 times by now 8 to the power of 3 over 2, which is 1.5, divided by 3. And from that, now we'll add 4. What are we going to have? 4, and then we will have times by, and we could write this if we wanted as 4 over 8 to the power of a half. This is x to the negative half, entirely up to you, 0.5, 8 to the power 0.5. And then from this, we're going to subtract now. Let's put this in. So we've got now 2 times, I suppose you can do some simplifying with this because we've got a 3 and a 3 here, entirely up to you. 3 to the power of 1.5 over 3. So if you want to simplify it, you can do. Plus now 4 over root 3, or 3 to the power 0.5. So let's go ahead and do that and find what that is. So that is going to give us now 10.7. So that's going to be 10.7 to 3 significant figures. Hopefully that's all looks good and legit. Right, let's do the last one. So sometimes we'll need to simplify, as we did in the last unit. It's no major issue. We just simply go ahead and multiply this out. So what we're looking at then is the integral from, we've got 0.5 or 1/2 to 1.5 or 3 over 2. So they're the x coordinates. Again, you might want to write them as fractions, you might want to write them as decimals. So if we do root x times by root x, well, that's going to just give me x. Then we're going to have plus 3 root x minus 2 root x, which is just going to give me 1 lot of root x. So that's going to be plus root x, or x to the power of 1/2. And then we're going to have now minus 6. So I've just simplified that. So what are we going to end up with then? Well, that's going to be now 1/2 x squared raised by a power and divided by the new power plus 2/3 x to the 3 over 2. And then we'll subtract from that 6x. And we're interested in this from half or 0.5. Again, you can write these as fractions or decimals. It really doesn't matter to that right there. Okay, so let's go ahead and do this. Again, I'm just going to put these values in. I would show my full workings in the exam. So what we've got then is the following. This looks a bit messy. So we've got now we've got 0.5. So we'll start with the 3 over 2. Let's put 1.5. So let's put 1.5 to the power. What have we got in here? 1.5 squared. So 1.5 squared over 2. Then we've got now plus what we're going to have 2 times 1.5 to the power of 1.5. So that's to the power of 3 over 2. And we're going to divide that by 3. This is messy. And then we're going to have minus. What's that going to be? Minus 9 if I substitute in now. So minus 9. Then from that, we're going to do the half. So that's going to be now a half squared is a quarter. A quarter times a half is 1/8. So I'll put that in. I'm simplifying if I can as I go. Then we're going to have plus, we'll have 2 times by 0.5 to the power 3 over 2, which is 1.5, divided by 3, and then we're going to have minus 3. So that's now in with the half, and that gives us now negative, it's in negative 4.01, and that is going to be correct now to 3 significant figures. So that is what we end up with. So all I've done is gone ahead, integrated and evaluated. If we look at this figure of negative 4.01, what I'm going to do now is just get a graphing calculator up, and I'll just type this in. It's just off the screen, but I'll put it in nonetheless. Let's just write it in and the function. And then if we look at that, there we go. Right, okay. So here it is. What I've done is essentially, if we look, I've integrated from this point right here, which is going to be now the negative, the 0.5 to now the 1.5, which is just here. So it's given us a negative answer. And the reason that is because it's below the x-axis. So if we were asked to find the area trapped between the curve, this particular curve right here, or the curve that it gives the integral of, that is what we're going to end up with. So as stated, we will look at that in a later video, but hopefully you're not too concerned now that it's coming up to be this negative figure. Okay, let's look at a couple more. In question 2, we're asked to find the value of the following definite integrals, giving our answer to 3 significant figures. So we've got the integral from 2 to 4 of 2x cubed minus 3x over root x dx. So as we did in the previous unit, we're just going to go ahead and split this up. So I can split the fraction, and we've seen plenty of this before. So I can write this now as 2x cubed over x to the half. Remember, root x is x to the half, minus 3x over x to the half. Then, of course, I can use the rules of indices to simplify. So what we're looking at then is the integral from 2 to 4. If we consider now 3 minus a half is 2.5, so this is going to give me 2x to the power of 5 over 2. Then we're going to have now x over x to the half is x to the half, so this is going to be minus now 3x to the power of 1/2, and we're integrating now with respect to x. So what we'll have is the following. We need to raise by a power and divide by the new power. So what we're going to have here, this is going to go to the power of 7 over 2. So all I'm going to do is simply go ahead and write this. Let's write this in. Raise by a power, divide by the new power. So if I divide now 2 by 7 over 2, I'm going to get 4 over 7. So let's do it. 2 divided by 3.5, what should give us now for 4 over 7 as expected. So I'm just kind of working half a step ahead to avoid too much work. And then what we're going to get now, this is going to be, so this will be x to the 3 over 2, so this is going to be 2x to the 3 over 2. And now we're interested in this from 2 to 4. So if I raise by a power, it'll be 3 over 2, divide by that power, that is going to give us 2. Okay, at this stage now, we could go ahead and substitute in. I'm just going to put it into a calculator and find out what it is. So what we've got then is now on here, let's put this in. We've got 4 times by, I mean, we could write this now if we wanted, 4 times 4 to the power of 7 over 2, which is the same now as 4 to the power of 9 over 2. You don't have to. I'll write it in 4 to the power of 3.5, and then we're going to divide that by 7. Minus now, we're going to have, what's this going to be? 2 lots, so 2 times by 4 to the power of 2 over 3. That's just going to be 16, isn't it? So that's going to be 2 times by 8. That looks good. Square root of 4 is 2. Okay, let's now do the 2. So what we're going to have is 4 times by 2 to the power of 3.5 divided by 7. Let's put that in. And then we will get now, from that we'll subtract now 2 times by 2. Again, you can simplify this if you want, 2 to the power of 1.5. So you could have written that as 2 to the power of 2.5. And that should give us what we want. Hopefully that's all in nicely. And that is going to give us now on there 1169.4 and so on and so forth. So 1170. So what have we got? 1170, and that's 3SF. Again, I'd show my workings in an exam. So that's what we end up with. So there we go. That's what we have. Let's just check that it's gone in okay. So 4 times 4 to the 3 over 2. That's going to be square root of 4. That's fine. Minus, right, okay, that's where we're going. Right, it looks a bit, let's go back in. Let's take that out. That's what I'm missing. Just thinking about that, looks huge. I need the minus there, don't I? Just, there we go. That's a bit better. 56.3. Always check, as you can see, 56.3. As you can see, it's quite easy to make errors in this. So 56.3, so 56.3, and that now is 3 significant figures. So do check it doesn't get outlandish. Right, next one, we want the integral, and we'll split this up again, the integral from 3 to 5. And now what we've got is 3x to the 4th, so 3x to the 4th over now x to the power of 1/3 minus x over x to the power of 1/3, and then we've got now plus, and we'll have 4x to the negative 1/3. We don't need to do anything with that, and that's what we have. So we're looking at the integral from 3 to 5. There are our limits. So what's that? That's what we're going to have, 3x to the power of 11 over 3, so 11 over 3. Then this is going to be minus x to the power of 2 over 3, and then we're going to have plus the 4x to the negative 1 over 3. So that's what we're integrating, so a lot of simplifying. So this is going to be equal to, what are we going to have? That's going to, I need to raise by a power, so this is going to be now 9 over 14 x to the power of 14 over 3. So if I raise by a power, it'll be 14 over 3. And then divide by that new power. So 9/14 x to the 14/3. And then this is going to give me now, if I raise by a power, that will be 5 over 3. So that's 3 over 5 x to the 5 over 3. Now, what are we going to have on this? This is going to be 1/3. So this is going to be plus 12x to the power of 1 of 2/3. Let's just write that in. So if I raise that by a power, that will be 2/3, won't it? So what's that going to give me? Divide that by 2/3. That's going to give me 6, isn't it? Plus So plus 6 to the power x to the power of 2 over 3. So that looks good. And now we're interested in this from 3 to 5. Again, very messy integral. We'll substitute in and then find out what our answer is to 3 significant figures. So again, be careful with these. I hope I've been careful as I've been going. As you can probably appreciate, it's easier to do them if you're not talking, because you can spend a little more time, but hopefully they should be good. So 14 over 3 divided by 14. No, we want to come out 14 over 3 divided by 14. Then we're going to, from that, now subtract, and then we'll have 3 times by 5 to the power of 5 over 3. So 5 over 3 divided by the 5. And then we will add to that now plus 6. So we'll have now 6 times by 5 to the power of 2/3. So let's put this in, 2/3. And then from that, hopefully the calculator will squeeze this in. In fact, I'll just do this as one calculation. So that's going to be now 1183.6. So 1183.6 dot minus. So let's just check I've got all of this in. That looks okay. Let's just check. 1403, that's fine. Okay, so all I'm going to do at this stage now is delete this and put in the 3. So if I do that, then we can subtract that away. Let's put the 3 in. So the 3 is going in, and then we are going to have now put in that there. That's going to be the 3, and that gives me now 117. So minus 117.04 dot. So what are we going to have? 1183.6 minus the answer. So minus the answer. 1066, so 1066.5 dot. So what's that going to be? 1 to 3 significant figures. 10. What are we going to have? 1070. So that's to 3 significant figures. That looks pretty good. And there we go. So that's what we have. Again, a bit of work in that one, but hopefully it makes sense, and hopefully that's been of some use. So there we go. We've looked at indefinite integrals in a previous unit. This is now definite integrals. Same process with polynomials. Raised by a power, divide by the new power, but we simply evaluate by taking the upper limit first and then subtracting the lower limit to give us an answer. If any of these have been slightly off, I do apologise, but again, talking through is prone to slight mistakes.